Okay. So last time we talked about basically logarithmic equation. We started doing logarithmic equation and logarithmic and exponential equation. Yeah. So let's go ahead and continue with that a little bit. Okay. Before I continue with this, let's do some techniques that we're probably going to use those into solving the equation. So let's go ahead and see if I can make expanding and contracting logarithm a little bit easier. Okay? Suppose we want to expand a certain log. Say we have the following log, say x squared times x plus 1 cubed, uh, say x squared plus 1, and we have x minus 3 to the power 4, 2x plus 5 to the power 3. Let's say we want to expand that log. Let's say we want to expand that log. And we want to use the properties of logarithms to go ahead and expand. If we follow step by step on that one, it's probably going to take us about 10 steps more or less. Okay. So let's see if we can reduce those steps, where we can combine all of these steps that it's going to take to solve this into one step. And hopefully that will be easy to do. Okay. When we expand these, that means every factor on top and every factor on the bottom must contain its own log. Okay? So we're going to start by the following log. Okay. What is the first factor in it? X squared. Let's not worry about the exponent. Okay? First, we're going to write what is inside. What is that factor? So this is a factor of x. So that's log of x. To determine how many log of x we have, we look at the exponent. The exponent is 2, so that means we have 2 of those. And this number was on top. We started with the top one, so it's a positive. Okay? So let's do the same thing for the rest of it. All the top ones will be positive. All the bottom ones will be negative. They all follow the same rule. The exponent in front, the base inside the log. Okay. So let's take a look at this factor. This is a plus, right? Exponent says 3, so we have a 3 log x plus 1. Yeah? Plus, we don't have any exponent, so it is just 1 log of x squared plus 1. We're done with the top. Yeah. When we start doing the bottom ones, now it's going to be simply the same thing, except instead of a plus, we're going to start with a minus. So minus, we have log, first we have 4 log x minus 3 minus 3 log 2x plus 5, and we expanded that. Easy enough? We'll probably use some of these in the solve. Okay? Now, how do I combine it all into one log? The same thing, except we go backward. Okay? So let's combine this into one log. Let's make it look like that. So let's not cheat. Let's take the top one away so we don't cheat. Okay? There you go. And I erase it completely. If I want to combine all of these, that means at the end of the statement, I'm going to have just one log. Yeah? So what do I start? Make sure first all the bases are the same. Yes? All of these logs have the same base. So that's good. Yeah? Step number 2 is just say log. fraction bar. Whether you're going to need a fraction bar or not, it really doesn't matter. Just say a fraction bar. Yeah? If we need it, we leave it. If we don't need it, we erase it at the end. Yes? All the positive logs, I put them on top without the log, just what's inside. Yes? And all the ones that are negative, we go on the bottom. And how many of them is your exponent? So the first log is x. Yeah? So x on top. How many x do I have? Based on that, it's x squared. So I'm just going to put a square right there. The next log is for x plus 1. So I'm going to open a parenthesis and say x plus 1. Because it's a positive. And how many do I have of those? That's your exponent. The third, I'm going to again open parentheses, because all of these must be multiplied. So we have x squared plus 1. Okay? We only have one of these, so exponent 1, we don't have to put it, right? Now we're done with all the positive ones. There is no positives here, right? If there is, I'll just add it as I go along. So I check each one by itself, regardless of what I have after. This one is a negative, so it goes on the bottom. So now we have x minus 3. This is the log. And we got an exponent of 4. Now remember, the negative doesn't go with the exponent. The negative just tells me where it is. After I know what it is, I ignore the negative totally. Okay? The second one is a negative, so it goes on the bottom. So it is going to be 2x plus 5, and then we have 3. So now we combine all of this into one log. Okay? Hopefully that is helpful with some of the homework that you're supposed to be doing online. Okay? So no matter how complicated or how simple it is, it always works that way. Okay? Now, if you do have a square root or cube root or what have you, you can always change the radical into a fraction, exponent. When you change it to fraction exponent, you just apply the same thing. Yeah? So for instance, if this happened to be 1/2, does that change anything? Only thing changes, this becomes 1/2. If you recognize 1/2 is the same thing as a square root, yeah, you can take the 1/2 off for the square root. So how does that, if this is your index, this is your factor, this is m, so this is the same thing as a to the power m over n. The bottom of the denominator of the fraction is your index. And the numerator is whatever exponent you have. If it is 2, it's a square root. If it's any other number, it is whatever that number is. So if this was a 3, then this would be, this would be a cube root, and so on. Okay. This was 2/3, the 2 goes inside. Hopefully that covers all the bases that you might have. Okay. So now with that explained a little bit more, and an example, let's go ahead and do solving. We start with basically with logarithmic equation. Okay, let's go ahead and do some examples. Last time we did a couple of examples. Let's go ahead and do this one today. It says log base 5 2x minus 3 equal 2. We have a property in logarithm says if we have a, say log base a of x as equals to x. Remember that? This is one of the properties that we have. Last time we said if we want to solve logarithmic equation, in order to get rid, if we have a log equal to log, I can just take the argument and set them equal to each other. Yeah? But in this case, we don't. How do I get rid of this log? To get rid of this log, I want to try to use this property. Yes? This property says if the base of the log raised to the exponent, its exponent had the same base log, yeah, then I can cancel those out. So what's the base of this log? 5. I can do this. I can say 5 raised to all of this. Log base 5 2x minus 3 e. Yeah? Because I said 5 raised to this, yeah? So this has to equal 5 raised to this. Yeah? Another way, if I have two numbers equal to each other, say if x is equal to say 5, I can say 2 to the power x equal 2 to the power 5. Why? Because x is exactly 5. Yeah? Same thing here. We have this and this are equal to each other, right? I can say any number, really, doesn't have to be 5. 5 is for convenient. Any number raised to that, other than 1, equal this raised to that. Now 1 is still going to be the same thing. It's going to give you 1 in either case. They're still going to be equal. But we want to try to put it in exponential terms. So the reason I use 5 is because I want to use that property. What happened when I use that property? These two come. So what is left? Whatever inside the log, so 2x minus 3 equal 5 squared, which is 25. Now it is simply a linear equation. Linear equation to solve it, you move the constant to the other side. So 2x equals 28, and x has to be 14. So if I say x is 14, 2 times 14 is 28. 28 take away 3 is 25. And then 25 is 5 squared. Yeah? What did we say about log? Again, property of log. We have log base a of a to the power x equal also x. Yeah? So here we have log base 5 of 5 squared. So log base 5 of 5 squared equal 2. Yeah? So that covers this particular question. And you can always check it on the calculator, see what the calculator gives you, if it gives you the right answer. Any questions? All right. Let's do another. Well, this is if it was a log equal a number. We approach it this way. What if we have more than one log? Say, for instance, we have log, and this time x minus Is it x minus 16? Yeah. Log of x minus 16 equal to minus log of x plus 1. Is it, I think it's x minus 1. Well, with this particular one, what do I have? First, it doesn't have, we don't have one log equal to another. Yes? Why? Because we do have a 2 over here. So we cannot use a log equal log and then solve. We don't have a log equal a number. Why? Because it's not the number by itself. It has another log with it, right? So that doesn't apply either. So how do I solve this? Well, I'm going to try to combine all the logs into one. And maybe then I can use the same technique we just did to solve. Yeah? Well, to combine all the logs into one, I'm just going to bring all the logs together into one side. So I'm going to say log x minus 16. This log, I'm going to bring it to this side, plus log x minus 1 equal 2. Now we can use the technique I just did at the beginning to go ahead and combine these. I'm not going to say whether I'm going to use a product rule or division rule. That's fine. But sometimes it's not obvious. Okay? So if I want to combine these two into one log, I said we put a log and then we say a fraction bar, right? Okay. The first one is positive. Where does it go? On top. So that's going to be x minus 16. We don't have anything else. Yeah? It's only one, right? How about the second one? Where does it go? It's a plus. It goes what? On top. Are we done with all the logs? Yeah? Did I need the fraction bar? No, I didn't put anything on the bottom. No. So we use the product rules. Equal. Now we have one log equal a number. I can use the exponential form, or that basically what I need. Yes? But I need to know the base of this log. What's the base of that log again? 10. If the log doesn't have a base written, it is known to be 10. So I can say 10 raised to the log x minus 16 x minus 1 equal 10 squared. Okay? So what's it good? All right. Now I can say, well, this is 10 to the power of that. This is 10 to the power of that. I can take the exponent, set them equal to each other. Don't need to, but these are gone, right? That's what I use this for, not to use the exponential. So we got rid of these. So what do I have? X minus 16, x minus 1 equal 100. So far so good. Well, now this is simply algebra. To solve this, we need to expand first and then see what we can solve. So x times x is x squared. X times negative 1 is minus x. Minus 16 times x minus 16x. Negative 16 times negative 1 is positive 16 equal 100. Okay. This is a quadratic. Let me erase these. In a quadratic, we have to move everything to one side. Okay? So that means we're going to bring this 100 over here. So what do I have? we have x squared minus x minus 16x minus 17x. If I bring this 100 over here, that is a negative 100. Yep. 16 minus 100, negative 84 equals. Now we have it equal to 0. Then we need to factor in order to solve. Again, how do I factor this? A is 1, so that is an easy way to factor. What is that easy way? We can see if we can find two numbers. When I multiply them, I get negative 84. And when I add them, I get negative 17. Now, let's analyze these numbers. Let's see what kind of numbers are they. When you multiply two numbers, you get negative. That's an indication one of the number must be negative. Correct? When I add two numbers and I get a negative, which one of them is negative, and the answer is negative when I add them, that means the bigger number in absolute value is negative. Okay? So let's see if I can figure out what those two numbers are. I probably don't know offhand. How do I find them? So I'm going to start with the simplest one. I'm going to start with 1, 2, 3, 4, 5, 6, 7, until I find those numbers. All right. So number you multiply by 1 to get 84 is 84. The bigger one has to be negative, yes? But obviously, if I put those together, I don't get 17. Let's go to the next one. 2. Is there any number you multiply by 2 to get 84? And we go 42. Yeah? And if I put those together, I get 40. Yeah? Not 17. I'm getting closer to 40, right? I mean to 17, what I need. First, I was like 83. Now I am 40. Good, so I'm getting closer. Let's see with the 3. What number you multiply by 3, you get 84. So that's going to be 28. This has to be negative, right? And those don't give me 17. But they're getting me closer to 17. They give me how much? 25. Let's go to the next one. 4 times what number? I get 81. 21. Okay? Do these give me 17? Yes? These are my numbers. I stop here. Okay. Now, if these were not my number, that means I need to continue. Yes? Let's ignore these two for a second. 5, I cannot use it because we can't find it. There is no number you multiply by 5 to get 84. That is a nice number, right? 6, however, we can say that 6, I get 1 and then 4. But notice here we went below 17. Yes? On this one, we were above 17. This one took me below 17. And if there is nothing between them, I stop right there. I don't have to continue because that means there is no two numbers you multiply, you get those. Okay. But in this case, we did have those. So we're going to go ahead and use those. But I'm just telling you where to stop. Okay? So you don't have to continue 7, 8, 9, 10, whatever. Just that's it and stop. And you can kind of like figure out how far you have to go. I mean, I didn't have to do 2 and 3 and all of this. I could have jumped from 1 to 3, for example, or skip some, depending how big the numbers are and how far away from the 17 one. But that's the worst case scenario, is to do one at a time. Okay? So now, We got our numbers. So this can be written as x minus 21, x plus 4 equals 0. So now we have a product of two numbers equal to 0. One of them has to be 0. If this is a 0, that gives me x equal 21. Yes? Okay? But if this is a 0, that gives me x equal negative 4. However, we need to, again, to go back and check our numbers to see which one is a good number. Maybe both of them are good. I don't know yet. Yeah? Or maybe none of them is good. I don't know yet. Okay, let's check. If x is 21, if x is 21, let's go back and put it into the equation. What's 21 minus 60? 5? Yeah? 5 is a good number. At this stage, I'm only looking whether it's a positive or negative. If I get a negative, I ignore it because if you remember, we said you cannot put a negative number inside the log, right? But I need to check every one of them. Here is a log, and here's also another log, right? So if I have a 21 here, right, I'm going to get 20. That's still a good number, right? So therefore, if all my calculations are correct, 21 should be an answer. And they are in this case. Okay? So go ahead and do it. If you're not, you can just put it in the calculator and see if you get the same answer on both sides. Let's try negative 4. What happened when I put a negative 4 here? What do I get? Negative 4, negative 16 gives me negative 20, right? Is that acceptable? No. Because we can't have a negative number inside the log, right? So we cross this number, and the only solution for this problem is x equals 20. That's the only solution for this problem. Okay? So now if we do have logs somewhere, we can just simply combine them together and put them into one log. Okay, let's do another example. Say, for instance, you have log base 2 of x minus log base 2 of x minus 1 equal 1. In this case, we don't have one log equal another log, right? I don't have one log equal a constant, and I need to have either one of those situations to solve. So how do I do it? Well, I got all the logs on one side. Let's combine them into one. So it's going to be equal log, again, fraction log. The first one is x. Now remember, this is 2, right? This is base 2. The first one is x. Let's look in the front of it. Is it positive or negative? Positive meaning it goes on top. Yeah? The second one is x minus 1. That positive or negative? Negative. Goes top or bottom? Bottom. We don't have any coefficients, so we don't have any exponents. Okay? Now, Now I'm going to try to use that property. To use that property, I need to have the base of this log raised to whatever that log is. Yeah? So what is the base? What's the base of the log? 2. So that means 2 raised to all of this. Log base 2 of x over x minus 1 equal, we do the same thing over here. We use 2, I'm going to use 2. Okay. So now what happened to this? So what is left is x over x minus 1 equal 2. We can make that 2 over 1. We can cross multiply. 2x minus 2 equal x. And this is simply a linear equation. We need to bring all the x's together. So what do I have? 2x minus, bring the x over here, x equal, if I take the negative 2 to the other side, I get a 2. Now, 2x minus x is x equal 2. And it looks like, let's see if this is a solution or not. Well, log, can I put a 2 here first? Yeah, it's a positive number, right? 2 minus 1 is 1. It's a positive number, so that's okay. You want to check the answers? Log of 2, log base 2 of 2 would be 1, based on the property. Log base a of a equal 1. Yeah? So those two are the same, then the log is 1. Log base 2 of 2 minus 1 is 1, right? So what's the log of 1? Then log base a of 1 equal 0. Yeah, that's all the time. Doesn't matter what the base is. So in this case, 1 minus 0 equals 1. That looks like a true statement. I think these are most of the type of logarithmic equation that you could have. Now let's take a look at some exponential equation. We have a to the power m equals a to the power n with, say, a positive not equal to 0 to 1, then m must equal to n. Okay. So here's what we have. We have this scenario where we have a base raised to certain power equal the same base raised to certain power, and that base is not 1, then those two power must be equal to each other. Yes? All right, so we're going to use this to solve a certain equation. Suppose now we have 3 to the power, say 2x plus 1 equal 3 to the power x minus 2. Well, this is simple enough. So the basis on this one, we have one exponential equal another, right? Same rules with the log. So what does that mean? The exponent must be the same. So then we have 2x plus 1 equals x minus 2. This is a linear equation. Bringing the x here becomes minus. Yeah? So we have x equals negative 2, negative 1. X equals -3, and that's your solution for this particular equation. Yeah? Now notice, in exponential, it's okay to have negative. And log is where we have issue with that. Okay, let's take a look at another problem. Okay, so these are okay. General rules, what if I have 3 to the power x equals, say, 5? And I'm trying to solve this equation. If a equal b, then ln of a equal ln of b. Two numbers are the same, positive, right? Two numbers are positive and they're the same, then their logs will be the same. Whether you say log or natural log, whatever base, it's still okay. Any log for that matter. So we have a 3 to the power x equal 5. 3 to the power x is a positive number. Because no matter what you raise that 3 to, always going to be positive. 5 is positive, yes? Now we need to somehow solve for x. How do I solve for x? In exponential or in logarithm properties, if we have log base a of x to the power r equal r log base a of x. This is one of the properties that you were supposed to prove for extra credit. Yeah? So in order to solve this, anytime you have variable in the exponent, to bring that down, you introduce log. Whether you use log, log, or ln, it doesn't matter. As long as you are consistent throughout. Okay? So let's use log. So I can say then log 3 to the power x equal log of 5. Yeah? Again, both of these have to be positive, and they are. Yeah? Now I can apply this property, and I can bring the exponent to the front. I can bring the x to the front. So I can say x log of 3 equal log of 5. Yeah? And how do I solve for x? Remember, log of 3 is just a number, right? So I can divide by that. Divide by log of 3. Divide by log of 3. So we can say x equal log of 5 divided by log of 3. So that will solve the equation. We got 4 minutes. Let's go ahead and do one more example and stop. Say for instance, we have just solve 3 to the power 2x minus 1 equal 4 to the power x plus 2. Okay? Same thing. We have exponential term variable. To bring the variable down, we use log. We introduce log. Yes? We can say then ln. I'm going to use ln this time. Same thing. 3 to the power 2x minus 1 equal ln of 4x plus 2. Now, let's bring these to the front. So 2x minus 1 times ln of 3 equal x plus 2 ln of 4. Yeah? Let's multiply. That'll be 2x ln of 3 minus ln of 3 equal x ln of 4 plus 2 ln of 4. And remember, all of these are numbers, yes? Doesn't matter. So again, this is a linear equation. To solve it, we bring all the x's together. This is an x, this is an x. Let's put those together. So we have 2x ln of 3 minus x ln of 4 equal 2 ln of 4 plus ln of 3. Yep. Well, we have x here, we have x here. I don't want to combine them together and put them in the calculator because I'm going to get a number that is not exact. Okay? So what I'm going to do here, because we do have x in common, I can factor x. So what do I get if I factor x? So we get x. What's left from here? 2 ln of 3. And on the second one, we have ln of 4 equal 2 ln of 4 plus ln of 3. Yeah? Any questions? So to solve for x, we divide by this number. By this number. So x equals 2 ln of 4 plus ln of 3 divided by 2 ln of 3 minus ln of 4. Okay? So that takes care of how to solve. This is, I think, this is the hardest one you can ever get on exponential function in this case. And any questions? No? All right, that's it. You guys have a good day. I'll see you back